Today I'll be introducing a few software tools that you can use for monitoring a Linux system actively or passively. And by active monitoring, I mean that you are viewing the performance data at the same time as the system generates it. And by passive monitoring, I mean that the performance data is usually collected in the background and analyzed or processed later. A lot of tools exist in the Linux ecosystem, and in this video I'll quickly demonstrate top, htop, nmon, and systot. All of these tools can be useful for analyzing the performance of the system, and they can aid you in finding potential bottlenecks that the system might have under a typical load. For this demonstration, I'll be using an ARM-based Raspberry Pi 4 with OpenCGX, which is an open and free-to-use embedded Linux distribution by MontaVista Software. First, let's take a look at top. Top is found in many Unix-like operating systems, and it shows you a lot of information at once, like the current time, the uptime of the system, how many users are signed in, the load averages over 1 minute, 5 minutes, and 15 minutes, general task state information, how the CPU has spent its time, memory usage, and swap usage, and then, of course, the currently running processes sorted by CPU usage by default. As we can see here, currently, top itself is the most CPU-intensive program. But if I start a stress test at the background, we can see instantly as it pops in and takes most of the resources. Top is a classic workhorse that exists in probably every Linux system, and it is a solid choice if you wish to minimize the amount of additional tools in your system. It's simple and effective, but bland, and the information is hard to digest in a short amount of time. Usually top is used for active monitoring, but technically it does have a batch mode, which you could use for passive monitoring, but I personally would not recommend anyone to do that. Here I have an example of the output saved to a text file. As you can see, the format is not easily machine readable, and there are far better alternatives available for that use case. htop is very similar to top, but it has additional features. It can show all the same things as top, but in a more visually appealing and mostly human understandable format. It can be configured to show a lot of additional information as demonstrated here. Let's quickly toggle disk I/O and network I/O in addition to the defaults. You can see they were added here. And let's put a stress test on so we can see a change in the output. It has also options for raising or lowering the program scheduling priority, killing processes, filtering or searching among the processes, and much more. If you need something that is relatively lightweight, that needs to be read by a human being, it is a solid choice. Whenever I'm on a new Linux system with installation privileges, this is probably the first piece of software I'm installing, because with htop it's so easy to very quickly get an overview of the system and its resources. Unfortunately, htop does not support passive monitoring in any way, because it is meant to be used as an interactive software. Then there's nmon, aka Nigel's performance monitor for Linux. Nmon is basically a toggle each metric you need version of htop. For example, if you wish to monitor only the CPU usage, just press C. If you also want to see the memory usage of the system, press M for memory. Then D is disk I/O. Maybe you wish to monitor the CPU usage over a longer period of time. Just press L to get a nice graph. The biggest difference nmon has in relation to top or HTOP, is the ability to actually store the data in a machine-readable format such as a CSV, a comma-separated value file. For example, this command on the screen currently would collect data every minute for half an hour and save the data in the current working directory. Here's an example I have generated earlier of the output. Anemone is a good choice if you want a single tool that can do active and passive monitoring in a relatively simple package. Then there's SAR, aka System Activity Reporter, which is part of a larger collection called Systat, which has multiple system performance tools for the Linux operating system. Systat contains tools for collecting and reporting all kinds of system data over a long period of time. What data is collected, how often, and for how long it should be stored is fully configurable. It can output the data to a CSV, XML, JSON, or even SVG format to be viewed or processed later. For demonstration purposes, I have configured Systat to collect data every 10 minutes via a cron job on this Raspberry Pi. Unfortunately, SAR does not have a nice dashboard that shows you everything at once, so we'll have to check these one metric at a time. For example, here we have the CPU usage that has been collected, and here we have the memory usage. Let's check the disk activity of a single disk, as we can see it here. I know for a fact that this does not use any swap, but let's check the swap usage. Yeah, that seems right. Then let's check the network usage of the primary network interface here. Yeah, there's barely been anything moving around here. The best part is that Systat can be configured to retain information for a long period of time, like weeks, months, or even a year at a time. And you can also output the results as a JSON file if the data needs to be aggregated somewhere else. Here's an example of the data. Or you can even create a visual representation of the data. Here's an example of a command that would generate a SVG of the disk I/O. And here's a sample of the output. Even though Systat and SAR require some additional setup to collect data, either through cron jobs or systemd timers, and forces you to basically check each metric one at a time to get the full picture, it is still a very powerful tool for monitoring a system. It can be used to detect load spikes, find bottlenecks, and generally monitoring the overall health of the system. It can handle active monitoring too, as demonstrated here, but better alternatives for that purpose exist, such as HTOP. I would recommend Systat when you want a feature-rich passive monitoring tool, but not the complexity of larger professional tools. You can find out more about these tools in the links provided in the video description.